All right, guys, so here we are working on a 2009 Grove gmk5220, and the operator's complaint today after speaking to him told me that he's got an active fault code for the transmission. So, seeing as how this is an Allison transmission, it's actually a 4500 series RDS with a Gen 4, we're going to go ahead and see what kind of fault codes TCM is broadcasting. We're going to show you how we can check the oil level directly from the shifter. So we go ahead, press the up and down arrows, we get oil level. This is displaying a fault in the level sensor circuit. So we're going to show you how to check fault codes here. Just hit the up and down arrow once more, and it's broadcasting a P0713, which is actually not the code I was called out here for, but at least you guys get the gist of it on how we can actually check our transmission oil level as well as fault codes. My apologies for the glare here, guys. My intent here is to show you guys the active and inactive codes. So we currently have the P0713 transmission fluid temp circuit, but there's also another inactive code, which is the P0726 engine speed input circuit performance. So that inactive code that you're looking at is the reason why I'm here today trying to figure this one out. This is a pretty hard way to diagnose something. They actually pull the codes mid-flight on the side of the road, which was at P0726. The complaint was of a very harsh downshift accompanied with a transmission limp mode afterwards. So we need to figure this one out. We're kind of on a tight deadline here, and I'm going to try and film everything that I can, but keep in mind that this is real jobs and I just film as I go. So let's say we visualize this transmission. So here's the transmission. It's actually a remanufactured unit. So this is a pretty big unit. It's kind of stuffed in there. Let's go on top and we'll see if we can get a better view. So I managed to find a little bit more information on this code. This transmission temperature sensor is incorporated into the internal wiring harness. The transmission control module supplies a 5-volt reference signal to the transmission fluid temperature sensor, and it measures the voltage drop in the circuit. The transmission is cold, the sensor resistance is high, and the TCM detects high signal voltage. As the transmission temperature warms to normal operating temperature, the resistance and the signal voltage decrease. The TCM uses this information to control shift qualities. So we'll run you through a bit of the testing I've done here. So it started off with just doing a visual. Took the TCM connector off at the transmission also, the 20-pin connector of the transmission. Just did a visual, nothing really abnormal, all the pins looked good. As far as pin connectivity, didn't seem anything abnormal there. During our tests, I ended up putting my multimeter on pin 18 and pin 19 of the transmission bulkhead connector, and to my surprise, I was reading somewhere between a spike of 8 volts down to 6 volts, which is still over the 5-volt reference voltage that it's supposed to be outputting to the transmission temperature sensor. I hooked up the oscilloscope to pins 18 and 19, which is the 5-volt supply for the transmission fluid temperature sensor, and it almost looks to me like we have a speed sensor that is kind of teed in here. This should not oscillate as much as it did. Remember what we learned earlier. This is a thermistor. This gradually changes resistance based on temperature. This signal does not indicate that. I think that we either have a bad harness or a bad TCM. So next I felt it was important to try to load test these transmission fluid temperature sensor wires. So now I have a battery pack next to me and I'm feeding 12 volts through these wires from one end of the crane to the other, and there's already a voltage drop. So I know that there's something wrong with the wiring and it's not a transmission control module problem. So as you can see, I'm applying a load with a test light. Even with 8 volts, the light should be on. It would be on very dimly, I should add, but it would be on. Monitoring the voltage when the load is applied is very important for determining if your wire integrity is okay. I'm going to pause the video here, guys, because I want to explain something. Based on our load test results, it was evident that there was an issue with the wiring harness. So that forced me to go from one end to the other and actually get my eyes on this harness, take it all out of the loom, and lo and behold, the problem was right there beside the TCM. I guess I just chose to start at the transmission first, but one way or another, we found the problem. Check this out. Look at the water dripping out. I've never seen one personally this color before. It almost looks like a painting. There's a little bit of green, there's some blue, some brown. I'm looking at some kind of grayish colors. I even see some red in there. This connector is going to be a hard one for me to beat. I wonder about you guys. Being able to bypass that connector, heat shrink and soldering each individual wire saved us some downtime and some expensive connectors. So now we are left with just performing a fault scan. By performing this repair, we are able to get rid of both of our fault codes and they shouldn't come back. So making these videos do require a little bit of effort on top of the already massive workload that I tend to have on a daily basis. So what I'm asking for is a little bit of effort on your end. So hit that like button, leave a comment below because I like to know what you guys are thinking, and don't forget to subscribe. This is Mitch at Diagnostic North, signing off.